Today's lesson is on section 3.4, the second derivative test. First off, the homework is section 3.4, 27 through 39 odd, and number 40. The second derivative test, well, it's like the first derivative test in which it is used to find relative extrema, your relative max or min, but it doesn't always work like the first derivative test. Sometimes the second derivative test fails. So let's take a look and see what the second derivative test is. The second derivative test is, let f be a function that f prime of c, remember c is your critical numbers, so that f prime of c equals 0. Then what? Here it comes. If f double prime, in other words, if the second derivative of that critical number, that output is greater than 0, it's positive, then f has a relative minimum at c, and then you plug that back into your original function. I want to know what point on my original function do I have that relative min or max. Or if after taking the second derivative and I evaluate it at that c, that output is negative or less than 0, then f has a relative maximum at that point on my original function. And here's where it can fail. If the second derivative, I evaluate that critical number and it ends up equaling 0, the test fails. And you must use the first derivative test to find out at that c, is it possibly a relative min or max, or maybe there's none. All I know is I can't answer it here in the second derivative test. So I'm going to proceed to just do one problem this evening, because the same directions will work for all of the homework. You're just using the second derivative test and then going back to the first when the second fails. So let's do a problem. The directions will read, find all of the relative extrema, use the second derivative to begin with, and of course, if one of the critical numbers fails, use the first derivative test. Well, the first thing I have to do is I have to go get my critical numbers. I take the first derivative, I set it equal to 0. Again, what does that mean? It means the slope of this particular function, what x values, is a slope of 0 back on my original function. So I try to factor, and that's a minus. When I take out negative 15 out of both, that becomes minus. That can be factored further. So 0 equals negative 15x squared times the quantity x minus 1 times the quantity x plus 1. Now let's go find all my critical numbers. I get 0 from setting this equal to 0. Setting this equal to 0, I get 1. Setting this equal to 0, I get a negative 1. I have 3 critical numbers. 3 locations on my original function f that I might have a relative min or max. Well, if I use the second derivative test, it's a little bit quicker for me to find out if I do have a relative min or max. So what I have to do, because it's the second derivative test, is I have to go and take the second derivative. So I'm going to bring down that 4, that's negative 60, x to the third power. Bring down that 2, that's 30 times x to the first power. I have taken my second derivative. Now I'm going to evaluate each of these critical numbers. I just plug it in and see if I get a negative output, a positive output, or if it fails and this output ends up equaling 0. The first critical number I'm going to test is 0. I literally just straight old substituted into my second derivative. It ends up equaling 0. It fails. I'm going to have to go and use the first derivative test on the critical number 0. Well, let's continue. I'm going to evaluate 1 in my second derivative. So again, I put 1 in there, it's just this. I put 1 in here, it's just this. It's negative 30. Most importantly, it's negative. Okay, that's information I need to write my conclusion. The last critical number I'm going to evaluate is negative 1. So I substitute negative 1 in here and cube it, substitute negative 1. So this is going to produce a negative times a negative, that's a positive. And then negative times a positive is negative, so my output is positive. So that's information I need to go finish up my conclusion for my second derivative test to find out relative min or max. So I'm going to make my conclusions right now on the 2 that worked. By the second derivative test, since f double prime of 1, when I evaluated that, I got negative answers, less than 0. Then f has a relative maxima at the point 1, 2 on my original function. That's 1 f of 1. So you can see I did the math down here. I put it back in my original function. Figure out what point on my original function has a relative min or max. Second, by the second derivative test, since f double prime of negative 1, when I evaluated that, I got positive answers, greater than 0. Then f has a relative minimum at negative 1, negative 2. All I have left now is to go back and evaluate this critical number to see if I can find the relative min or max. So I must use the first derivative test on x equals 0. So what I did is I went ahead and I created the sign chart, but I wanted to write all 3 critical numbers. I only need to focus on what's happening on either side of the 0, but I wanted to write that out so I accidentally didn't pick those as my test values. Again, with my sign chart, I put down f prime and f. So for the first derivative test, I'm going to take those test values, plug that back into f prime to find out the signs of f prime. So I had to pick negative 1/2. Not so much fun. So I'm going to take that negative 1/2 to the 4th power. And what is that going to be? That's going to end up being a positive 1 over 16. So negative 15 times 1/16 says you're negative 15 over 16. Negative 1/2 squared is negative 1/2 times negative 1/2. That's a 1/4. That's where I got 15 over 4. I went ahead and multiplied this by 4 over 4. So I could see that this was a 60. This was a negative 15. All I need to know is that this is a positive output. I put positive here. Again, back at the first derivative test, I'm going to take my other test value, 1/2, plug it into my first derivative because I just want to know the sign of my first derivative. So I put in my 1/2 again, but because these are even exponents, it turns out to be the same answer as before, which means I'm going to end up with a positive result. So that means my original function is just increasing and increasing. I do not have a relative min or max. So since f prime does not change at x equals 0, then f has no relative min or max at x equals 0. And this does not happen every time when you test with the first derivative test, when a value fails on the second. Sometimes there is no relative min or max, sometimes there is. And I'm done. Thank you.